So yesterday we did ellipsis, and we're going to do ellipsis again. But now just the equation has changed. I'll move it up, you guys. This time we have an H and a K, and now we know, and our foci has changed. Okay, so you have to make sure you're looking at what standard form it is and whether or not you have an H or a K. Again, your major axis, your minor axis, those equations haven't changed. Those are still the same. C squared equals A squared minus B squared. That's still there. The only difference is really the equation and how it affects the foci, the vertices, and the covertices. So here's our horizontal. We just wrote that. And now we're going to focus on our vertical. And then, of course, we're going to do an example. And I know how much you guys love doing examples. Okay, so these are our new equations. And what we're going to do now is we're going to write an equation for an ellipse. So I'm going to show you the problem. We're going to copy that down, and then we'll do the example together. So here is example 2. So go ahead and copy that down. Okay, so you guys, yesterday when we did example 1, we had several steps. So we're going to follow the same steps that we did yesterday. So step 1 is to find the center. Now you guys, when you go to do your homework on this, when I give you the page, remember that to find the center, you're not going to write find center. You're just going to do it. So how do you find the center? Yes?
Midpoint.
Yeah.
The vertices.
Yep, we're going to use the midpoint. And we're going to use the vertices. We'll talk about the covertices in a second, but what we're going to do now is we're going to use the vertices. So to find the center, you use the vertices, and we're going to use that midpoint formula. So the midpoint formula says add the x's together. So -3 plus 9 divide by 2. And then we're going to add our y's together. 8 plus 8 divide by 2. And our center would be, what is -3 plus 9? 6. What is 6 divided by 2? So 3. And then 8 plus 8? 16. And 16 divided by 2? 8. So our center is 3, 8. That means this is our H and this is our K. So we know that when we go to put it in the equation. Okay. Step 2. So you guys, yesterday in example 1, we did the same thing. Find the center. We used the midpoint, the same thing. Okay. Now yesterday our center was 0, 0. Today our center is 3, 8. Step 2 is find the value of A. So you guys, these are the steps that you have to follow so that when you're going to write this equation, this is what you have to do. So to find the value of A, yesterday we used the distance formula because we have to find that length of the major axis. And you guys, your vertices are always on your major axis. So listen to me again. Your vertices are always on your major axis. So to find the length of it, we're going to use the distance formula. So use the distance formula. I'm just going to put I meant to put formula up here. Okay, so the distance formula would be D equals x2 minus x1. So x2 is 9 minus x1. So 9 minus -3 squared plus y2 minus y1. So 9 minus -3 is 9 minus -3 is 12. So this would be 12 squared. 8 minus 8 is 0. 0 squared is 0. And what is the square root of 144? Okay, yesterday we learned that the length of the major axis is 2a. Okay, so you guys, the major axis, the length of it is always equal to 2a. Well, our length is 12, so 2a equals 12. So again, let's just write a note that we're using the major axis equation. So you know where that came from. 2a, we wrote it down yesterday. And now, how do we solve for a, you guys? How would we solve for a? Divide by 2, so a equals 6. 12 divided by 2 is 6. And you guys, in our formula, do we need to know a or a squared? We need to know a squared. So what is a squared? A is 6, so 6 squared is 36. So now we know a and we know 36. So in case we need another a, you guys, the reason we converted it to a squared again is because that's what we need in our equation is a squared. Okay. Again, you guys, we know that this is a because we use our vertices. Okay, now, right now I can't tell you if it is horizontal or vertical. We'll know that once we find b. Step 3 is to find b. Now, you guys, these steps, the reason that I'm making a big deal about these steps is because these are the steps you're always going to use. You have to find the value of b. Because you need all of this information to write an equation of an ellipse. So, this time it says find the value of b. You guys, the co-vertices make up the minor axes. So, the vertices make up the major. The co-vertices make up the minor. So what we're going to do is we're going to use the distance formula again. But this time, instead of using the vertices, we are going to use the co-vertices. So here we go. D equals the square root of, well, our co-vertices are 3, 12, 3, 4. So it's going to be 3 minus 3 squared, x2 minus x1 squared, plus y2 minus y1 squared. Are you guys doing okay so far? What is 3 minus 3 squared? 0. So 0 squared is 0. What's 4 minus 12? Negative 8. What is negative 8 squared? And what is the square root of 64? 8. Okay, now that's the length of our minor axis. So what we need to do is, what's the formula for the minor axis? Instead of 2a, it's going to be 2b equals 8. So again, we're using the minor axis. And you guys, the minor axis is always 2b, the major axis is always 2a. And what is b? 8 divided by 2 is 4. Now, what is b squared? 16. Now, we have all the information we need in order to write this equation. Okay, so here's step 4, is write an equation. So it'd be x minus 3 squared over 36 plus y minus 8 squared over 16 equals 1. Now, we know it's that because if we go to graph it, we can see we can see where if it's vertical or horizontal, okay? And so that's our equation. There any questions? Okay.